Welcome to Energy Talks, a regular podcast series featuring expert discussions on power system testing, data management, cybersecurity, and important trends in the power industry. My name is Scott Williams from the podcast team at Omicron, and I will be your host. Hello, everyone. In this episode of Energy Talks, I speak with Omicron safety expert Florian Rein about designing state-of-the-art safety features into power system testing equipment. Florian describes the multifaceted aspects involved in this essential area of device development based on his recent experience when developing safety features for the OMICRON CMC 500 protection relay test set. Florian emphasizes the importance of identifying and adhering to applicable safety standards, understanding user behavior with testing devices in their day-to-day work, and conducting thorough risk analyses to ensure that all necessary safety requirements are addressed. Florian also describes the significance of third-party labels for verifying product compliance, such as CE and TÜV. Lastly, Florian highlights best practices not only for maintaining safety compliance throughout the product lifecycle, but also for setting completely new benchmarks for device safety in the electrical power industry. So without further delay, I welcome Florian Rein to this episode of Energy Talks. Hi, Florian.
Hi, Scott. Thanks for having me.
Well, it's great to have you here. Florian, what is your motivation for working in the field of safety?
Yeah, actually, it is a really interesting topic, as you have to consider a lot of different aspects, and I would say it never gets boring. So just to mention some points you have to consider during your work in the safety topics, there would be ones, for example, device behavior. And what is interesting, you get an overview about multiple devices, multiple behaviors, and you recognize that each device has some special and unique functions you have to consider, and also important stuff then to be aware about. Another thing is the user behavior. So you have something in mind usually during the development, but when you go into the field or talk with the field experts, you will recognize that they do something completely different you wouldn't have thought about before, or nobody would have thought about before. And that is really interesting to see.
I think that is a very important point. Every user has a particular way of working.
Yes, definitely. And also they grow. So the people themselves also develop during their work time and during their lifetime. And it's also really interesting to have this communication somewhere established. Doesn't matter if it's direct contact with a customer or if it's a contact over a sales representative or a technical support guy, whatever. But it's really important to catch up with the customers and to have this conversation. Besides that, also the equipment under tests behavior is really interesting. So as a safety expert, you're also interested in the safety of your equipment under test. Another thing which many people, I would say, maybe don't think about are cultural aspects. When you have to consider, we in Austria, we have a common way of working, I would say, and compared to in the European Union, I would say that's kind of standardized. But when you look to other countries around the world, this can be completely different. And also the user behavior can be different. On-site regulations can be different. And we have also to consider a little bit during the device development that the users can fulfill those requirements, that they are not standing in front of the plant they want to enter and can't enter it with our devices because they can't fulfill the regulations there. And for sure, additionally, environmental conditions, and what is also pretty interesting are often technical limitations to find kind of some possibility to have it usable and safe. An example to give you those, let's say, two worlds between usability and safety would be already a simple cable. With a test set, you want to output as much current as possible usually. So it should be as small as possible, as much current as possible. And the cable should be as flexible as possible. But a high current leads to heat on the cable. And this must kept into or below special limits or defined limits. And this means the cable gets thicker and less flexible. So this is always challenging, I would say. And that keeps me motivated in my job, that I have always some challenges and news to consider.
Definitely good points, many to consider. Florian, you've been involved with the development of a safe relay test set. Can you tell us what that is and more about your role as a safety expert and how your work contributed to the development of this safe relay test set?
Yeah, so the test set we are talking about and we are pretty proud of is the CMC 500. You've for sure heard about it already.
Now, the CMC 500 is the next generation of CMC technology. Can you tell us what that technology does?
It is a protection relay test set. One of the most common functions is testing various protection functions of relays. With the CMC 500, we really want to set a new benchmark in terms of safe test sets. With the special new safety functions, we want to set a clear position on the market with a high focus on safety. To give an example, Volvo stands for safety. When you take a CMC with you, you want to be sure that you can work with it safely and properly. And we want to bring all this safe behavior to a next level, I would say. And inside this CMC development, I acted as a safety expert. And here I took all the interfaces for safety topics during the whole project phase, then drove the risk analysis. So the risk analysis are a really important step for the product development. And the risk analysis is always a team effort. This is really important to know, I would say. I keep an eye on product safety standards. This is also a really important topic. As a member of the national subcommittees, I track the changes in standards pretty good and know how to interpret those standards for the devices.
You had mentioned preparing a risk analysis. What is actually in the risk analysis? What does it communicate?
So the risk analysis is capturing risks which are not captured in a product safety standard. This is the sense of risk analysis. At the product safety standard, it's defined how you build an inherently safe product. So from the inlet to the outlets, the product is safe. It does not cause any hazards by its own. It's not possible to get an electric shock by the housing, for example, or surfaces are not too hot that you can't touch them anymore. This is defined by the product safety standard. Then we connect something to the device. And here comes the risk analysis into place, because the product safety standard does not know what you connect or what the user is really doing with the device. And with this risk analysis, we analyze exactly those use cases, those things what the user can do. We have to analyze foreseeable misuse and the normal use. And this is really important for me to mention, that we also analyze the foreseeable misuse, because in the field you are in stress. As a user, you have to get your job done fast. There, something could happen. And we have to analyze this and consider it in development. And this is the task of a risk analysis.
So you're saying really there are things that could still go wrong even though you're following a standard.
As we use the product safety standards are harmonized standards, it is ensured that they fulfill the essential safety targets of the European directives. A standard is written for a big group of devices. So our standard is called Safety for Laboratory and Control Equipment. Do you hear it already? It's a big group of devices. So there is, for example, also SCALES is a laboratory device, which has nothing to do with test set as we know it. So their interpretation is really an important point. And as a manufacturer, we do the interpretation. It's really useful to be on a subcommittee or technical committee of the standardization, to be pretty near to the source information, to also have a possibility to discuss with experts.
Very good. Would you say that product safety standards are minimum requirements, that the instrument must fulfill at least what the standard is telling you?
Yes, this is the correct wording, I would say. This is exactly what it is. It's the minimum requirements, but usually you have to consider more.
That's where your risk analysis comes into play.
Definitely.
In terms of personal safety, there's some key terminology that needs to be differentiated. Florian, could you tell us the difference between commonly used terms?
Yes. So first of all, I would like to mention the difference between danger and risk, because this is mixed up pretty often. So a danger refers to a source of harm or a dangerous situation, whereas a risk includes also the likelihood. So the risk is really how often can a danger happen, so that a user gets hurt. And we do a risk analysis. So a danger alone would not be a problem, but if it is combined with a likelihood, then it's getting a problem. We're talking always about risks and risk analysis, not danger analysis, because the danger analysis is not saying anything, right? What is also important to mention standards, as we have heard already, but what I would like to mention here is some terms regarding standardization. So we are talking about additions, corrections, and amendments, because you have a number of a standard and then you have an addition, amendment, or a correction. And here the additions are, I would say, major changes. So this is a completely new version. They are usually really big stuff was changed. An amendment is a minor revision. And here the technical progress requires a fast change of the standard, but not a massive one. Therefore, you do an amendment that it's faster and you still keep up with the technical progress. And then corrections are just considering bugs. So as everything, also standards can have bugs, and with corrections, you correct them, as the word already says. Yeah, and this shows already a little bit how fast the standards are changing, that you need to consider amendments and not only additions. The reason for this is the technical progress, which is going to be faster and faster in the electrical industry. Therefore, also we as a manufacturer have to consider often changes and keep up with the progress. Another topic in terminology is labels and certifications, just to mention one, the CE declarations, for example. I would like to mention here 4 standards. We have the basic product safety standards, which define the inherent product safety. So this is the 61010-1. This gives the basic safety requirements. Then we have the -2-030. -2-030 gives an extension to the -1 for special measurement circuits. For us, especially required for the AFV inputs. So therefore, we have to consider another extension. This is the -2-030. Often, this is commonly known as a multimeter standard. In addition, we consider with the CMC 500 the ISO 13849-1, and this is now the additional standard coming as a requirement from the risk analysis for functional safety. So we define the risk analysis as a safety function. And another one, which is really important for the users, as they have to consider it in field, is the EN 50191. This is defining erection and operation of electrical test installations. So important for the users, not really to design the product, but what is important for us, that we design the product that the users can fulfill this standard then in the field. So we have also to consider this one, at least to know it. Those are, I would say, the most important standards in terms of safety for the CMC 500. For different products, we have also to consider more or different standards, but this is now, let's say, for the CMC 500, the most important standards we used here.
So now regarding the CE and TÜV labels, could you please give us more details about how they play a role?
So first, talking about the CE label. CE is a special label required or mandatory for many products for the European Economic Area. This is mandatory, for example, for low voltage devices, toys, electronic products, machinery, and so on. Everything where the directive or the regulation is requiring a CE marking, you have to put it onto the device. What is important is it shows compliance with applicable directives or regulations, but it is only a self-declaration. So the manufacturer is declaring compliance with the applicable directives or regulations and also standards. The TÜV label is a third-party approval. So they are really somebody who is not involved into the full process or the manufacturing itself or inside the company, is checking your device again after you have checked it already. So this gives an additional level of compliance, I would say, because another group of experts is looking at the device, and you have to imagine also those people have another network behind them. So you really get a complete different perspective on the testing of the device. And I think this is really giving a different level.
Very good. So are these labels required worldwide or only in certain regions?
So the CE label is only required for the European Economic Area. There are comparable labels worldwide, like an RCM mark, which is required for Australia, like a KC mark, which is required for Korea, and so on. So really, every economic area has its own label and requirements we have to follow. The CE is just an example, and usually we start with the CE as we are here in the European area, and we know the requirements best. So we start with those requirements and then check out the international requirements. And here it's really good that usually all the requirements are derived from international standards. The TÜV label is not mandatory. This is just a non-mandatory safety label we want to achieve to have this higher level of compliance.
Excellent. So how is it possible to fulfill all requirements for the safety compliance of a product?
I would say the most important thing is timing. So you have to start the activities in advance to the development of the product. This is the most essential thing to mention here. Because here in advance, you can really change the product itself. If you are getting too late involved to the project, or the topic gets too late involved to the project, you can't change or you can't do massive changes anymore. And safety is doing usually massive changes. Therefore, it is important to identify the standards in advance, to start the risk assessment in advance. And the risk analysis never stops. During the full development phase, it is continuously updated. Even after the development phase and during the full product lifetime, the risk analysis is a living document. Then you create safety concepts because you need requirements to hand over to everybody, and also doing good reviews, also with external parties like TÜV. This helps or brings additional quality to those concepts. And what is not perfect in the concept is then not perfect in the device. So the concepts really deserve the time you invest in. And another really big point is communication. A good communication is really, really important for safety. And also you talk to developers, so therefore it's really worth it to talk and to explain and not only to hand over some requirements.
Very good. And to involve them at an early point in the development. Is that true?
Definitely. Safety is something you should start as early as possible. Already when you think about a new project, you start with the safety investigation.
Especially when you're in the field of working with electrical power. I'm sure that's one of the primary considerations in the very beginning.
Definitely, yeah.
Did you want to say something about safety concept reviews?
For the safety concept reviews, you do a big round and you invest a lot of time into this because the concept is important for developers, for the product managers, for mechanic guys, and so on. So here you have to invest a lot of time as you have really a lot of persons involved. Afterwards, when you go to later stages, to more detailed stuff like schematics, the round gets smaller and smaller.
Florian, what important topics must be addressed in a safety concept?
Yeah, so I can mention some examples because the safety concepts are really big things, I would say. So to give some examples, it would be, we talk about isolations between circuits, for example. So I think this is pretty easy to understand when you have an charger for your mobile phone in mind. So there is a mains connector and there is a USB connector, and you don't want to have the mains voltage on the USB port because otherwise you could get hurt and the phone will be destroyed. So therefore you need to consider isolations in between. And these isolations also must withstand all the environmental conditions and must fulfill the requirements during the full product life. Then another point is components. Safety relevant components need additional consideration and more consideration than normal components, as you have to check certifications, reliability data, and so on. Examples would be transformers, right? So materials like housing, it's not just you build a housing. You have to consider material specifications like flammability when you have plastics involved, robustness. So there are special tests you do for safety reasons that the robustness over the full lifetime is guaranteed and the safety is not influenced by some events. To give an example, you drop a ball which is 0.5 kilogram heavy from a meter onto all positions of the device. And then there are also other aspects like ergonomic aspects, lights, chemicals, and so on.
Earlier you mentioned the latest OMICRON test set, the CMC 500. OMICRON claims it sets a new benchmark for personal safety with this device. What exactly is this new benchmark?
Here I'll mention first the newly introduced safety functions. So when you know the device, you could see it already. This is the safe and active signal lights. Then we have the interlock key, the operational mode button, and the residual current measurement on channel 4 of the U and V modules. And what are doing they now? So with the safe and the active signal lights, you can see if the device or the device state, is it safe or active? Already the names say, right? With one, just look at the device and you see it. It's easy to really have this feedback. Then the interlock key, you can be sure that the device does not output any signals during you doing your wiring. Really brings a big advantage to users which work, for example, where multiple people are around. We have the operational mode button, and here the big advantage, or for me a massive advantage, is you don't have to switch off the device to do a wiring. You just press the operational mode button, it goes to a safe state. You see this at the safe and active signal lights, and you can go to do your wiring. Your test set will not output any signals. And the last one is the residual current measurement. And here we measure current on channel 4, which still could flow after you switch off the outputs when an inductive load is connected. These are the safety functions, and I would say also the newly introduced isolations are a new benchmark. For example, we have from one input module to the other input modules on the AFE module to the next AFE module, we have a reinforced isolation established. We have also from the DC input to the inputs a reinforced isolation. From the output group to other output groups, we have reinforced isolations. And also from an output group to the inputs, we have reinforced isolations.
Could you briefly describe what you mean by a reinforced isolation?
Yeah, a reinforced isolation is defined in the product safety standard to be reliable enough to protect a user during the whole entire life just by isolation. And here we protect the user based on the application. So the reinforced isolation is doubled a basic isolation and gives a high reliability or the highest reliability in terms of isolation.
Florian, why did you decide on these new safety functions?
First point is for me the risk analysis. So the risk analysis gives the basic inputs for having new safety functions. Then you start with the concepts, and there it is really important that less is more. The user should be able to operate the functions really easy, and the safety functions shouldn't be complicated. And there it is really a difficult topic to find the sweet spot between safety and usability. Another thing is we have a lot of experience from the existing devices, and this was also included into the risk analysis and into newly introduced safety functions. And in addition, we have a lot of usability experts. Our technical support is communicating a lot with the customers who was involved in those investigations, and also a lot of other channels where we get customer feedback. So all this led to these safety functions I mentioned before.
Very good. And this again referred to as a new benchmark in test set safety. Is that in terms of Omicron or within the industry itself?
Here I would say within the industry itself. When you check out our safety section, this is really completely new. I've never seen something like this before.
When you're out talking to users in the field, of course, they tell you about other instruments they use or have used and maybe offer you comparisons in terms of safety features. Does that happen to you as well?
Yes, what we heard before we introduced the new safety functions is that users would like to have safe and active signal lights. And here now I'm really glad to see that we were able to introduce it at the CMC 500, and we gave it also a reliability that you can really rely on this, because this is really important for us that if we show a green safe light, that it is really safe, right? From the device perspective.
Florian, you mentioned earlier finding the sweet spot. Do you have an example of this during the design of the CMC 500 safety functions?
Here I would like to mention the lamps. With 2 lamps, you can show a lot of states. So you could have different colors, different blink codes, and so on. And here our approach is keep it simple. We have a green safe lamp, we have a red active lamp. And still, with a green safe lamp and a red active lamp, you still could show a lot of states with different blink codes and so on. But we decided just for 5 different states, which are shown with those 2 lamps. So, first of all, as mentioned already, off lamps are off. And yes, this is also a state we have really to consider. And this shows either an error or the power supply is missing. For the user, it is considered like an active state. Then we have the green lamp, and this just shows safe. Then we have the red lamp. This shows an active state, does not matter if it blinks or if it's continuously on. The red lamp slow blinking is a feedback or information for the user that the outputting is active. So when you press the play button in Test Universe, and the red lamp fast blinking is showing that an active discharging is in progress.
Okay. When you say discharging, what do you mean by that?
Discharging can be an internal discharging of the device. So also we have elements inside the device which store energy. And that could be an internal discharge of the device or the measurement on the channel 4, the residual current measurement, which is done on the channel 4. And if an inductive load is connected, we have to discharge it first, and only then we can show that the device is safe for wiring.
I understand that the CMC 500 has many applications as a multi-testing test set. How is it possible to take them all into account and still have easy-to-use safety functions?
Yeah, it needs really accurate and detailed safety concepts. So the safety concepts are not that easy to understand and simple as the usage of the safety section itself. Here I would like to really give you a feeling how many things need to be considered. We had 3,500 requirements to follow, to implement, and to test. So this was a massive testing effort. And in the end, what is the most important thing? The user needs to have it simple and easy access, as the users are often stressed under time pressure and so on. In the development, we can take the time to consider details, but the user really needs to be fast and have it easy to use.
Basically, users want to perform their test and not have to think about what the device is doing in terms of safety. They expect these features to be automatic, and you've done that for them. So by providing users with automatic device safety features, you take the burden off of the users to worry about. Is this a fair assessment?
That would be the target, to take some burden from the users into the devices.
Very good. Now, you mentioned a long list of requirements. Now, I assume from what you have been telling us that some of these requirements come from the standards, the minimum requirements from the standards you had mentioned before. Maybe others come from findings in your risk assessment.
We have more requirement levels. We go from top level requirements to more detailed requirements step by step. First, we start with the usability. Even before considering the detailed safety requirements, we start with the usability. And then we add the safety requirements to it. This is the first step. Then we go to the more detailed safety requirements, conceptual things. And then you go down to the software, hardware requirements, and also there in different levels. So this is a little bit how the requirement engineering works. And on every level, you have to do testing against those requirements. And this is then called a V model. So you go from top level to low level requirements. You do the implementation on the bottom of the V, and then you go up again with the testing phases. And at the end, there is a validation.
Would you say that your list of requirements qualifies as a benchmark?
Yes, we could express it like this, but I think it is nice to give an example with numbers, right? You get a feeling.
Very good. Yes. Well, I think we all understand now. What are the best practices to reach a maximum level of personal safety and improve it continuously?
So most important thing here is involving and listening to customer feedback wherever it comes from. Doesn't matter on which channel it is. Is it devices which are sent in for repair? Is it active feedback? Is it talks during a fair or whatever? So this is really a massive point. At the devices for repair, it's not only the feedback, it is also a detailed investigation. So if we have the feeling that safety could be involved, we do detailed investigations about the incoming devices. And really, we try to find the root cause for the issue. And here it is really valuable if you have a good contact to the customer, and the customer can express what he has done with the device, what application was done, because all this makes a difference to find the root cause. It is important to know and understand the applications as good as possible. So also here, continuous exchange with our application experts and understand issues and problems in fields. So For example, last time I was going with an application expert to a relay cabinet and we're trying out some contacts. So this also belongs to the job. How does it feel for a customer? Monitor trends in standards and law in detail, as it's changing all the time, I would even say, to keep up with the technical progress. Also, a participation in the National Standardization Committee helps a lot to be pretty close to the source information. Perform a third-party testing, like with TÜV, as a second pair of eyes, and all his network is checking the device from a completely different perspective. Really important detailed safety messages in the user manuals and application notes. So we know it all. Usually the manuals are like, yeah, they are here, but who needs it? So I would really recommend to read the user manuals. We invest a lot of time into formulating safety messages and useful notes and hints and so on. And last but not least, and really important, is start early with safety concepts that you really can change something.
Very good point. Florian, thank you very much for sharing your knowledge and experiences with developing safe relay test sets like the OMICRON CMC 500 in this episode of Energy Talks.
Thanks, it was a pleasure.
And a big thank you to our audience for listening to this and other episodes of Energy Talks. We always welcome your questions and feedback. Please send us an email to podcast@omicronenergy.com. Omicron has several years of experience in power system testing, data management, and cybersecurity, and offers a matching solution for your application. For more information, visit our website at OMICRONenergy.com. Please join us for the next episode of Energy Talks. Goodbye for now, everyone.